Hi friends, welcome back to my channel on statistics. In the before videos, I explain about unbiasedness and unbiasedness consistency with examples also. Unbiasedness and consistency. We all know that what are the best estimate properties means unbiasedness, consistency, efficiency, and sufficiency. Generally, we say that these four. Now we discussed about unbiasedness and consistency before. Now we can discuss about efficiency. What is the role of efficiency in estimation means unbiased estimators are infinite, consistence also maybe. Efficiency means if for example we have one parametric family distribution from I have xi random for samples from normal distribution with mean mu and variance sigma square. Okay, we all are know that here x bar is an unbiased estimate for mu and median also unbiased for mu. That time we are going to test with consistency also. Here x bar is also consistent estimator, median also a consistent estimator. Now which statistic I can select means that time we can apply efficiency. Understand, here x bar is also unbiasedness consistency and median also unbiasedness and consistency in normal distribution. Now the case is how I can select test statistics. Best test statistics means in this case I am apply efficiency rule. Efficiency rule means I can just find out the variance of x bar and variance of median. Which has less variance, then I can select this variance of median. Okay, I will find both median variances, then which has less variance, this is efficient estimator compared to the other. This is the general rule of efficiency. Now we can discuss formal definition with examples also. See, I am take this result from FMS book, Fundamentals of Mathematical Statistics book, and unbiased estimator. Sorry, this is from BL Agarwal. Okay, BL Agarwal book. An unbiased estimator Tn is said to be an efficient than any other. Here two test statistics are there, Tn and Tn star. Okay, if and only if this is condition is satisfied, variance of Tn less than variance of Tn star means variance of Tn is the efficient estimator compared to the variance of Tn star. If you need to find the relative efficiency, then you can write like this: relative efficiency equal to variance of Tn star divided by variance of Tn. Also this is also one result. Kramer gives the term efficient estimator to mean a minimum variance bound. I discussed already this term. Unbiased estimator or best unbiased estimator, however MUB estimators is unbiased and also among the class of unbiased estimators process a minimum variance. Okay, this is the general result. Now we can see some examples also. After we go into the minimum variance bound also. This is question. Most efficient estimator means we are already discussed this. Which has less variance, it is most efficiency. If in a class of consistent estimators for a parameter there exists one whose sampling variance is less than for any such estimator, it is called most efficient estimator, means less variance. Whenever such estimators exist, it provides a criteria of measurement of efficiency in other estimators. Okay, now we can see some examples. See, this is some first example. A random sample x1, x2, x3 up to x5 of size 5 is drawn from normal population with mean mu. Consider the following estimator. These all are the test statistics. Here T1 is x1 plus x2 plus x3 plus x4 plus x5. What this says? Now we need to check their unbiasedness or consistency, and which is best. Final question is find the lambda or T1, T2 unbiased question mark. State, give reasons. The estimator which is best among the T1, T2 treaties. For checking unbiasedness, we know that just we find the expected value of this by observing. We can say that it is x bar formula. X1, x2, x3, x4, x5 means 5 times mu divided by 5 is equal to mu. Here you got unbiasedness. So T1 is unbiasedness. T1 is unbiasedness. Okay. Now the question 2 is T2 equal to x1 plus x2 by 2. Here you got mu. Again you are getting mu. Means 2 mu you got here. 2 mu. So it is not unbiased. Okay. This is not unbiased estimator for population mean. Okay. When you can check this, they already says that here unbiased estimator for mu. So mu equal to 2 mu plus mu 3 mu plus lambda. 3 mu plus lambda mu divides 3 mu. Okay. When you cross check these conditions, finally what you got, 3 mu equal to 3 mu plus lambda mu. Here what is the value of lambda means 0. Lambda is 0. So it is also unbiased estimator. It is also unbiased estimator. For checking efficiency, you can just find variance of estimator T1, variance of estimator T2, variance of estimator T3. Which has less variance, we can select this. Okay, this is the question. Now we can move to another example. This is x1, x2 and through random samples of size 3 from a population with mean mu and variance sigma square. See, these 3 are our estimators or estimates. T1 is x1 plus x2 minus x3 and T2 is 2x1 plus 3x3 minus 4x2 and T3 is this thing. Now our T1, T2 are unbiased estimators. See, here mu plus mu minus mu, here T1 is unbiasedness. When you go coming to this 2 plus 3 5, 5 minus 4 1, it is also unbiased. Okay, question 1 is complete. Question 2 is find the value of lambda such that T3 is unbiased estimator for mu. Here already says that it is mu. The expected value of T3 equal to mu. When lambda equal to 1, here you got 3 mu upon 3. Finally you got mu. So lambda value is 1. So, lambda T3, yes, T3 is consistent estimator because when you find variance of T3, okay, that I think it is not consistent. We can conclude last. Best estimator means you can just find variance of 3 estimators, then you can which has less variance, we can take this. Okay, this is second important result in efficiency is minimum variance unbiased estimators. There are for minimum variance unbiasedness you need to satisfy two conditions, that is unbiased for gamma of t, and it has a small variance among the class of unbiased estimators. This is important. It has a smallest variance among the class of unbiased estimators of gamma of t. Okay, this is generally rules. Expected value of t equal to gamma of t and variance of t is less than or equal to variance of t star. Okay, now we can see some results are there in minimum variance unbiased estimator. Important theorems. See, a MUE is unique in the sense of T1, T2 or MUE estimator. See, it is unique. Unbiasedness, consistency, these all are not unique. MUV are unique. You can, for proof, you can refer book also. This is also another result from coefficient of correlation. This is also another result from this question. Theorem is important for objectives. See, if T1 is MUB estimator of gamma of t and theta belongs to capital theta and theta T2 is any other unbiased estimator of gamma t, if the efficiency E equal to E naught, then the correlation coefficient between T1 and T2 is rho equal to root E. This result is important. You can refer book also for proving purpose. Okay, this result also is important. If T1 is an MUB estimator of gamma of t and T2 is any another unbiased estimator of gamma t which efficiency E is less than 1, then no unbiased linear combination of T1 to T can be this is also okay. After efficiency, we can discuss about sufficiency examples with different definitions are there for sufficiency also. We can discuss all things also. Thank you for watching. If you have any queries, comment me.